To the fourth day of the GAN session. So today we'll start with the lecture by Professor Takata on end of life management.
Okay. So good morning, everybody. So this is the second last my presentation, and this time I would like to talk about the end of life management. Of course, end of life treatment includes reuse, recycling, and final disposal. But today I want to focus on the reuse management. So I'm not so good at recycling, material recycling, so I would like to talk about the reuse management. So there are variations in using product and parts. Product use, there may be a heavy user, middle user, light user. So depending on the users, the way of the usage is different. If you look at the part use, a kind of the part of the life is almost same as the product life. But there are other parts which can be reused or used for 2 life cycles of the product. Or you need to change the parts during the 1 product life cycle. So there are several ways of the usage. And our purpose is to exhaust the lifetime by product part reuse. The purpose of reuse is to exhaust the lifetime of items by using them multiple times in order to reduce the environmental load and resource consumption in their production phase. So product reuse means that the product has a long life, and this life should be exhausted not only 1 user but 2 users or 3 users. So that means the product life is shared with multiple users. On the other hand, part reuse means that part life is shared by the product 1, product 2, and product 3. So it is shared with multiple products. So again, the objective of reuse is to exhaust the lifetime of product or parts through multiple users or multiple products to reduce the number of products or parts needed to satisfy the requirement or needed to satisfy the users. And there are several ways of the reuse. One is the time-sharing reuse. So if a user A uses the car during the week, so but the user B used the car weekend, only weekend. So in this case, if the user A and user B shares one car, you don't need two cars. You only need one car. So this means that sharing the one product makes the usage rate higher, and you need less product than not sharing. Another way of the reuse is called the person type reuse. So which means that the products are passed to another user and then another user. So why this type of the reuse is possible? Because there is a difference in required functional level. So if the required function level of user A is this level, in this case, the user A satisfies with the product in this period. But user B may have a lower required function level. So in this case, the product used by the user A could pass on to the user B, and user B uses the product in this period. So in this way, the user A and the user B can use the one product and exhaust the product life. Also, there are another way. I mean that user A and user B has difference in usage rate. User B uses the, let's say, car very frequently or intensively, but user A uses the car less intensively. So in this case, user B exhausts the car in this period, in this time, but user A can use the car and how can I say that he or she remains the life. So if user A and user B changes the product at this point, then during the usage time, the life of the product can be exhausted. So you need, in this case, you need one product and two products, third product. But if you change at this point, then you can need only two products. Okay, so as I told already, there are many ways of the reuse. So product reuse, open loop, closed loop product reuse, and open loop product reuse. And also there are part reuse. And part reuse can be part reuse in production, producing the new product. And also it can be reused for the other spare parts. That it's called spare parts reuse. And also there are open loop part reuse in other market or in other product. So, but what is important is that you need a kind of the difference to be successful of the reuse. So, in general, you have a supply and demand, and supply and demand should match each other. And in case of the reuse, some kind of the difference make reuse possible. For example, difference in level of functional requirements among purposes or among users. So, as I told already, or a difference in level of function requirements among users, difference in amount of usage among users, or a difference in period of usage among users. This makes time sharing possible. Or a difference in period of usage between products and parts. So these differences is quite important for making the reuse possible. So from the point of reuse management, we should match supply and demand in terms of timing of collection and level of functional requirement. So again, if you look at the product reuse, you can categorize into spontaneous, in terms of the means of product collection, required functionality. So means of product collection, that means whether who decide to the end of the life. So if the user or the customer buy the product, then customer decide when it discard or when the product end of life product is. But if the product is provided like a leasing or renting, then the end of life can be decided by the operator. So you can plan the time of the collection. If the spontaneous collection and providing the same function, so used car, reconditioning, copy, and so on. So, but if the providing the different functions, for example, mobile phone can be used for alarm clock, or toothbrush is used to cleaning tools and so on. So this is the a kind of the cascade reuse or the open loop reuse. And the planned collection and providing the same function means that the rental service, mop and mat rental service, a copy machine, and so on. Also, the part use is categorized in terms of the product collection, spontaneous collection, planned collection, and required functionality, providing the same function or providing different function, and so on. So there are some kind of examples of this combination. So I mean that there are many aspects to categorize the reuse, or the many ways or many variations in reusing the product or the parts. And also there are many level of the treatment in reuse. So just clean up. So second-hand car is sold just by cleaning up. But reconditioned copy machines, there are reconditioned copy machines that is once disassembled, partly disassembled, and cleaned and replaced consumed parts and so on. So, or remanufacturing, completely disassembled and make it the product, reused product, as the same level as a new one. But yeah, as I told you that there are different levels of treatment for recovering the functionality. So, but it depends on the persons, or these. There are certain level of the differences, but there are no fixed definitions. So someone says that the remanufacturing should be should provide the at least the same functional level as a new one, but sometimes better. So because the machine could have a initial failure at the beginning of the life. There is certain kind of the defects in design or in manufacturing, and then if you correct them and used to become a steady operation, that is more reliable than the brand new one. So someone claims this way, but it is not so always true, of course. So, but that means that there are no fixed definitions. But anyhow, it is true that there are level, the treatment level. There are some multiple treatment levels in reuse. Okay, so some examples of reuse. This is a very old example, but very early stage of this kind of the circular manufacturing, and this is the case of the copy machines by Fuji Xerox, closed loop system, and they extract the parts usable parts from the returned product and then used to produce a new machine. Of course, they checked the condition of the parts, and they have a lot of data how each part how long the life each part has. So then they can assure the reliability or the quality of the parts, which is used to the new production of new product. So, do you know this type of the camera? Single-use camera. So, it is also classic one, but because of the smartphone. But in 1990s, they are sold many single-use camera, and the camera is produced by Fujifilm company, and they established a circular factory, automated circular factory for the single-use camera in 1998. This camera is the customer uses the camera to take photos, of course, and then after that they bring their cameras to the shop. So you cannot extract the film from the camera, so you need to bring your camera and then ask to develop the photos. So in this way, the way of the how can I say, product management includes the automatic return of the product to the shops and then to the factory. That is a unique characteristics of this type of the product. And then in the circular manufacturing factory, the camera is disassembled automatically and cleaned up, and battery, lens, shutter mechanisms, and so on are reused. And just the outer body are shredded and make a plastic pellet, and then used for making the new bodies. So this all process include the part reuse and the material recycling. And this is a case of the construction machines, mining machines, in the case of the Komatsu construction machine company. So they collect the used parts like engines and cleaning, disassembling, inspection, and so on. So these machines are used quite heavily. Then the machine deteriorates during the usage, and you need to exchange the parts. But the operation rate is quite important in this kind of this machine. So if you think about the mining machine, so how the machine operates is quite important to get the material from the mine, and therefore the lead time for the repair is quite, the supply of the part is quite important, and it is much easier to supply the parts from the reused part than the newly produced parts. So if you have to produce new product or the parts, then you need a certain period of time. But in case of the remanufacturing, so you can shorten the lead time of the providing the parts. And remanufacturing automobile parts has been long executed in many countries. So maybe in India, maybe in the United States, and also in Japan, such as alternator or starters. And the alternator or starters are disassembled and change the parts and clean and supply. And this was already showed, but this is an example of the tire retreading. So this is again the case of the copy machines, and this is the case of the Ricoh company, and they call them reconditioned copier. And by using this kind of the system, you can reduce the environmental impact by around 80% in the production phase. If you look at the environmental impact of the whole life cycle, the reduction rate is about 30%. Why this difference? Do you know? The most big environmental impact is produced by the paper in the case of the copier. So the user uses the copy machine to make a copy using the paper. And if you think about the life cycle impact, this type of the impact should be included in the calculation. So the life cycle impact consists of not only the production phase or material extraction phase, but also you need to think about the usage phase, like cars. And so this is kind of the way of the assessing the effects of the reuse or the reconditioning of on the life cycle assessment. And this is again the Ricoh case. So the data is a bit old, but we interviewed with the Ricoh company and get this data. So let's say 1,000 copy machine are sold to the users. Then the 80% of the end-of-life copier can be corrected by the recall. Some are just discarded by the user, or the exported, or the left as it was. It is so maybe 20% are disappeared from the control of the manufacturer. But anyhow, so 800 units can be corrected, and then they are brought to the local correction center and check the models of the copy machines. So not every model can be reconditioned. So certain time span or the certain model can be reconditioned. So by this check, the 800 unit is reduced to 160 units. Only 25% can be reconditioned. Then they are corrected to the correction center and inspected again whether the condition of the copy is appropriate for the reuse. 65% of the machine is proved to be reused. That means 152 units can be remanufactured, sent to the remanufacturing factory. So, roughly speaking, only 15% of the sold machine can be reused in this system. So I think the recall remanufacturing system is well established and very well managed. But even though the units which can be remanufactured or sold as a reconditioned machine is quite limited. So this example shows the difficulty of the effective reuse. So therefore, we need the method to improve the effectiveness of the reuse. How we can improve the 15%, the ratio of the 15%, make this figure more. So there may be different kind of the ways, maybe, but I'm showing I want to show the 4 examples of the method. First is reusing parts for multiple generations. So if you look at the one model, the sales period is limited. In the case of the copy machine, roughly 2 years. So this is the period of the one model is sold. And these models or these copy machines returns to the company this is just not the actual data, but this shows the kind of the number of the reclaimed product has this kind of the distribution. So that means it takes a bit time until the product returns. So if the parts which is assembled in one model can be reused for the same model, then only this portion can be reused because the product are produced during this time only. So we call the marginal reuse rate, which means the number of the reusable parts divided by the total number of sold product. So if the parts it can be only for the product, one product, then the possibility of the reuse is quite limited because of this marginal reuse rate. But if the parts used the for example, first generation product can be reused in the next generation product, then the marginal reuse rate become much larger than the first case. So commonize the parts to the multiple generations product is quite effective for making the part reuse. So this is one way of increasing the possibility of the reuse. And the second one is determining the optimal sales period. So as I already said that the sales period is limited. So and this is a schematic diagram, but let's say this is the sales amount of model A, model B, model C, and the model is changed every 2 years, and the model A will return like this way and corrected, reconditioned and sold as a reconditioned machine. But in a certain period, in this case, you need to recondition the certain model. So when you should change the model of the reconditioning machines. So this is the question in this case. So again, this is the sales quantity, sales volume. This is the return product, number of return product, and this is the recoverable product. That means the machines are checked by the model, by the condition. So if you set this period as a sales period, then you can have a potential sales volume is like this one. But if you change the sales period, the potential sales amount increases and have a peak around this. So in this case, starting sales from 42 months after the release of the base machine retain the largest amount of potential sale. So which period you should recondition certain model, reconditioning machine of certain model. So in this way, so you need to think about this, how can I say, the change in the model or the sales strategy, and the reconditioned machine, the sales of the reconditioned machine should align with this sales strategy. Okay, so these are the actual cases, but another two is just research-based method, but I'd like to explain about the module reconfiguration, remanufacturing, and inter-office faucet circulation. Okay, again, every 2 years or every several years, you have a change in the generation of the product, and also the return product changes like this one. And if you look at a certain point in time, the model which is new model or newly produced model is only one in each period of time. But if you look at the return model, for example, here you have a return model of the first generation, second generation, third generation. So that means the return products include multiple generation products. Not one model does not return. And in general, each generation model or the second generation model is superior than the first generation model. So that is manufacturer's strategy to improve in certain level of the functionality. And in this case, let's say, just for example, performance 1 means quality of the copy. Performance 2 means speed of the copy. And there are many users, and user A may have a requirement, higher requirement in terms of the performance 2, and but performance 1, he or she does not have any strong requirement. So she can be satisfied with lower speed, for example. But she want to have a very good quality of the copy. But he has another requirement. He copies a lot of papers, so he wants to have a high-speed machine, but he doesn't care the quality of the product or quality of the copy. So, but if you have a first generation and second generation, in this case, you only reuse the second generation product to satisfy the user A or user B. So the first generation product doesn't satisfy the user A or user B. But if the product has several modules, and let's say M1 module is contribute to the quality of the copy, and M2 module is contributed to the has a more complete contribution to the speed. Then if you change the module or the reconfigure the module, then you can have a product with different performance than the original one. And in this case, you can reuse the two products by exchanging the modules. So in this way, depending on the user requirement, if you can reconfigure the modules, then you can increase the possibility of the reuse or possibility to satisfy the users. So how this kind of the method possible? So first, identify required performance values of each user group. So we need to categorize the users into some users group, and also calculate the realizable performance values of the remanufactured product with reconfiguration pattern. So there are several modules, and how you can exchange the modules and reconfigure them, and what level of each performance can be realized. So that should be assessed first. Then you can have a different reconfiguration patterns, and you have a different category of the different group of the users, and how they should match. That should be optimized. And we assume that each module, the functionality of each module has a certain amount of the impact to the performance, such as copy speed or the copy quality. So this kind of the matrix should be identified from the engineering point of view. And then, as I told you, that we should categorize the realizable performance value and required performance value and match between them. So if the realizable performance level of the remanufactured product are higher than the required performance level in all levels, then the product can be provided to the user. So this is the criteria. And we applied this type of the concept to the copy machines again. And in this case, performance indices are image quality, power consumption, usability, the user interface, paper jump frequency, waiting time. Waiting time means that if the power is off, then you put on the power, you need to wait a bit time until the copy machine working because it needs some period of time to heat up the machine. And that was already a bit old example. So at that time, we collected the data from the middle speed monochrome copy machines. So as I told you, 5 performance indices and 12 modules of the copy machines we identified. And we assume that the product models are changed every 2 years, and the platforms, you know that the design of the copy machine is, how can I say, you developed a so-called platform which can be used, for example, the 6 years. But the model will change every 2 years, but by using the same platform. So in this way, how can I say, the efficiency of the designing the new machine is accelerated by using the platform design. So the modules with the same platform could be reconfigured. So if the platform changes, then you cannot reconfigure the modules. So the interface will change. And this is a kind of scenario, platform A, B, C, and every one platform, you have a 3 generation product. And we made a life cycle simulation to evaluate the effectiveness of this type of the method. We assume 3 cases. Case A is only new produced products. Case B, reuse but without reconfiguration. So I mean that the company sells reconditioned products and newly produced products at the same time. Case C, so this is the case where the reconfiguration management is introduced. And I just want to skip the details of the calculation, but this shows the result. The horizontal axis is the time, and case A, the vertical axis shows the cost multiplied environmental load. So we need to think about the environmental impact as well as the cost. So of course, in each model, you can introduce a way of the reduction of the environmental impact. So even though just a new machine, newly produced product could reduce the environmental impact. But in case B and case C, you can reduce the environmental impact to satisfy the user's need. So user requirement are same in 3 cases. So we assume that if the provided required function is higher than the user's requirement, then user can buy the machine regardless of they are newly produced or the reconditioned one. So reduction of cost is 16%, reduction of environmental load is 13% in this case. Okay, so another example is also the calculation of by the research, but the idea is just a moment. Inter-office circulation. Again, this is also the case of the copy machines. Let's consider the copiers used in an office with multiple sections, such as university or the company's office. So there are many sections, and each section may have copy machines. But each section has a different usage characteristics. Some section uses a copy machine very frequently. Some section doesn't use the copy, doesn't make the copy so many. So again, we assume that there are certain level of the differences in usage or in the use of the machines. And we assume that copier manufacturer makes a blanket contract to provide the copiers in all sections for a certain period of time. So the company has a contract to provide the machine to every sections during the certain period of time. So this type of the how can I say, the contract can be possible. The manufacturer periodically exchanges the copiers among the different sections based on the usage characteristics of each copier, while satisfying user requirement in each section. So as I told you that some section uses a lot of makes a lot of copy, and another section doesn't make so much copies, and each section has a different requirement in terms of the quality of the copy and so on. So the question is how we can circulate or how we can exchange the copy machines to exhaust the lifetime of each machine and to reduce the amount of the machines to satisfy the user's needs for a certain period of time. So we need some models in this case. So the user have certain copier functional requirement which is expressed by UR, and Q is the required value of quality characteristics. Quality characteristics of copiers again are the image quality, electricity cost, noise level, operability, frequency of occurrence of the jam. So almost the same items which we assume to the last example. And there are certain level of weight in each quality characteristics. So some user put more weight in noise levels, and some user put more weight than the operability and so on. And this kind of the weight is evaluated by the so-called conjoint analysis. That is used the method to get the user's characteristics in the market science area. So anyhow, so we make a survey to calculate the weights of the quality, and survey was made in the university offices. For the functionality of the copiers, we assume that the physical deterioration and the obsolescence function. Obsolescence function means that every 2 years or something, new machine appears, and then how can I say, the functional level decreases. The old machines, functional level of the old machine decreases because of the emergence of the new machine. So we calculate the functionality by multiplying the physical deterioration and obsolescence function, and calculate this kind of the function. So now the how we should rotate, or how we should exchange the machines. We calculate, or we optimize this kind of the exchange schedule by using the genetic algorithm, which I told you yesterday. And the objective function is to maximize the functionality utilization rate, because this is a functional level and this is a time, and the functional level deteriorate in a certain level, but if you stop the usage of the machine, then you can use this area. But the total area is this one. So how much is the used area? Is the functionality utilization rate. And there is a constraint that the customer satisfaction should be more than 1. Okay, so I will skip the detail of the calculation, but anyhow, so we applied the genetic algorithm to get the optimum schedule of the reallocation of the machines. And these are the user's characteristics, and these are the change in the electricity cost, operability, and so on. So we collected the data from the company, and also we estimated from the questionnaire survey and so on. And we evaluated 3 scenarios. Intra-office circulation scenario, that is the scenario which we are proposing. And second one is a lease scenario, leaving product return to user discretion. So if the level of the functionality becomes less than the user requirement, then user returns the machine. But the machines are not reallocated. The lease scenario 2 means user used the same copy machine for 5 years by comparison. So you need to use for 5 years that machine, regardless of the level of the functionality. So 5 years is a common period of the lease contract in Japan. And this is the calculation, and this is some examples of the result, and this shows the average functional usage level, and this line shows the average customer satisfaction. So this is a circulation scenario, a lease scenario 1, lease scenario 2. And if you look at the lease scenario 2, the average functional utilization rate is not so different from the circulation scenario. But if you look at the average customer satisfaction, circulation scenario, this scenario, in this scenario, the satisfaction, user satisfaction should be maintained 100%. But in this scenario, you need to use the 5 years compulsory. So you cannot change it, although you are not satisfied with the fully satisfied performance of the machine. So therefore, the percentage of the average satisfaction, customer satisfaction, becomes lower than this way, this circulation scenario. And if you look at the LCA, the characterization scenario has the lowest value. So the LCA is calculated by the CO2 emission, and interoffice circulation reduces the CO2 emission by approximately 20% and 10% as compared to the least scenario 1 and 2. So to make this kind of the method effective, you need a certain number of the machines. Just 2 machines or 3 machines may not work this kind of the system. So we checked how the number of copy machines affect the results. So this is average functional utilization rate, and this is the reduction rate of the environmental load. So this calculation shows that more than 10 machines, this type of the strategy can work. So, but this is just this case. I'm not saying that in general more than 10 is necessary, but I'm not saying so. But in this case, only 10 machines, then you can apply this kind of more than 10 machines, you can apply this type of the strategy. Okay. Summary. There are many variations in reuse. Although reuse is one of the most effective life cycle options, it is not easy to match the original use and the subsequent use. To solve this problem, we have proposed several reuse management strategies, such as part reuse for multiple regenerations, identifying optimal sales period, module reconfiguration, remanufacturing, and inter-office faucet circulation. There could be other management strategies, of course. We need to select proper strategies depending on product characteristics and user characteristics. Maybe also you should consider the market characteristics. Okay, thank you very much for your attention.
Thank you, Professor. If audience any questions. Not once again next time.
Okay, thank you very much.
And there will be a short break now.